Alright, in this video we're talking about translations and lines in 2D. Now normally when we describe lines in something like methods, we're talking about y equals mx plus c, and that would be m being the slope and c being the y-intercept. But that gets really tricky when we're talking about a line, maybe it's at 4, 3, and it's going in this direction with vector 1, 2. Like, you'd have to figure out the slope and the y-intercept, which is a bit annoying. It turns out that it's a lot better to describe this line as maybe the equation we'll times this by something called lambda. It's going to be 4 plus lambda and 3 plus 2 lambda. And that basically describes every point on the line. Because this point here is lambda equals 0, you would just get 4 and 3. But if you wanted to look at the point lambda equals 1, you'd be getting the point 5, 5. Because if you put in lambda equals 1 there, you get 5, 5. And then you can keep going. If you want lambda equals 7, you're going to get the point 4 plus 7, so that's like 11. And then 3 plus 2 times 7, so that's 14 plus 7, that's 17. You can even go back, you could have lambda equals minus 1 and you get a point corresponding to that. And all those points trace out your straight line there. It's a bit weird, but it actually turns out to be a lot more convenient. So let's talk about this bit here. Translate the point minus 3, minus 2, 3, 5, 1. So essentially we're just going to be adding 5. So for part A, that's going to be 2, and minus 2 plus 1 is minus 1. So this would sort of be the value for lambda equals 1 on our line. Speaking of the line, here's a vector equation. Essentially what it's going to look like is it's going to look like the original point minus 3 minus 2 plus lambda times our direction vector 5, 1. Or if you want to simplify that down, it could look like minus 3 plus 5 lambda and then minus 2 plus 1 lambda. There we go. By the way, the word that I keep saying is lambda, and it's a Greek letter. It looks like that. Okay, sometimes people use a t if they want. Speaking of which, we can use a t for this equation. The vector equation of the boat would be 3 plus 5t and 2 take 4t. And essentially what this table is asking for is a position at any time in seconds. So the position here at t equals 0 is going to be 3, 2. Now at t equals 1, you're going to get 8, 2 take 4 minus 2. At t equals 2, you're going to get 3 plus 10, so 13, and then 2 take 4 times 2, so 2 take 8 is minus 6. And then here at 3, you're going to get 3 plus 15, so 18, and then 2 take 12, so that is going to give you minus 10. And you can see here, the y coordinates are going down by 4 each time. And then the x coordinates, they seem to be going up by 5 each time, and that directly corresponds to these numbers here. And this is probably ringing bells from vectors. It is very similar to what we did back there.